Hello everyone and welcome to the tutorial on how to set up and use the Ultimate C++ Interaction Framework plugin. The main purpose of this plugin is to provide a clean, modular and multiplayer-ready interaction system for Unreal Engine. With this plugin, you can quickly set up interactable actors using interaction definitions and plug your own custom interaction logic into a fully event-driven, multiplayer replicated workflow. You can also enable or disable interactions at runtime, which is ideal for things like quests, puzzles, etc. The framework also includes a built-in target highlight system using outline or overlay material, so players always get clear visual feedback about what they can interact with. The plugin is highly optimized, fully written in C++, and all key functions, parameters, and events are fully exposed to blueprints, so you have full control over the system. If you want support, have any questions, or want to connect with other developers, you are warmly welcome to join our community on Discord. Without further ado, let's get started. Okay, so currently I'm in the Interaction Framework content directory, and all of the things you can see here, also all of the things you have in the map, they can serve you as a good example of how we have set up the interaction with interaction targets. So if I open up the blueprints directory, over here we can find interaction character. If I open this up, you're gonna see here interaction input. So basically what we are doing here, we are calling try interact function. What it does is that if our detector component has something in its trace, it's gonna try to interact with it, and on completed, when we release the button, we're going to cancel interaction. This is important because we have implemented also the hold functionality, so we have to know when the player released the interaction button. Okay, on the left you can see that I've already added interaction detector component over here, and in the details panel you can see all of the parameters we can change. For example, we can change the max trace distance, meaning how far we will trace for interaction targets. The trace channel, by default it's set to visibility. We can also define the trace mode, meaning we can do the line trace or capsule trace, or either you can do your custom trace. If you want to use custom trace mode, all you have to do is to select this option, and then back in the interaction detector component, you need to override perform interaction trace function. If you override it, you're gonna get function like this, and in here you can do your custom trace, for example, multi-line trace by channel, and you're gonna do your setup and plug the hits in the out hits over here in the return node. If you choose the capsule trace, you can also change the capsule radius and capsule half height. Then in the highlight section, we can enable or disable highlighting the interaction target. So if I turn this on, you can also change the highlight stencil value that you have to use in the material. If I get set up like this, the system will always use the outline material that is binded to the, for example, player camera. So if I go back to interaction character, and click on the camera, go into the post-process rendering features, post-process materials over here, you can see that I've added the mi_outline material, which basically has the stencil value of 2, so it listens to this value. Another parameter we have provided is highlight component tag, which is very useful if you got more meshes within one actor and you want to apply outline only to certain of them. Okay, so if I go here into the level, you can see that these two meshes are within one actor, and if I hover over them, only cube gets the highlight. It's because I've added the tag on the cube, so the system is ignoring the sphere mesh. And the last but not least is to use highlight overlay. So if you take this on, you can add the overlay material over here. Let's look at the example. So in here we got the overlay material. So if I hover over it, it's gonna get the overlay material. If the overlay material is not being used, the system will automatically use outline material when the highlight is enabled. Okay, now let's open up one of the interactable actors, for example, this door. And in here you can see that we have added the interaction component. There are 3 important sections that you will find in the details panel up here. So the first one is in the interaction section. It's the interaction definition. If we open this up, you can see that it's type of interaction definition. So if you want to create your own data set, you would just go here, right click, go into miscellaneous data set, and you're gonna type interaction definition. And in here, we got a bunch of parameters. For example, default interaction enabled, default interaction time. If the time is 0, it means it's instant interaction. But if we type here value bigger than 0, for example 1, the system will consider this interaction to be a hold interaction. You can also define maximum interaction distance for each interaction target. Then we have here auto end interaction, to which we will come later. Interaction priority. This is useful if you got, for example, capsule trace on your interaction detector component. So in your capsule, there could be more than one interactable targets. The one with higher interaction priority will be considered for interaction as first. Then in the hold section, we got the hold progress mode and the default hold progress decay rate. All of these parameters could be individually overridden on the interaction component, so you don't have to create data assets for each individual interaction target. Basically, you can define some default basic interaction definitions, and then if you want to change some setting individually, you can just override the value, and that's it. One more thing to mention, for UI, you can set the interaction label and interaction icon. Interaction label is meant for the action. So for example, to open door, to pick up, and so on. And you can also define the icon, which appears after the interaction label in the UI. If we scroll down at the bottom, you can see that we have some events here. These events should help you a lot since it makes the code more cleaner, modular, and easier to read. For example, in the door interaction, I have implemented the onInteractionStarted event, on which we are just playing the timeline component and setting the door relative rotation. So basically we are opening the door. However, if you look at more complicated code, for example, this door, which is considered to be the repeatable interaction, as you can see, we have already the onInteractionStarted as well. However, we are setting the state of the door. So if the door is open or closed, then we are deciding if the door is open, we're gonna play the timeline component. If not, we're gonna play the reverse. However, on the finished, we are doing the reset interaction, meaning we can interact with the object with the door again. And if you go in here, you can see that if I press the F key and the door opens, now I can interact with the door again, meaning so I can close it. Okay, back to the auto and interaction variable. If it's true, the system will automatically end the interaction for you. Meaning, if the interaction time passed by, it's gonna call the onInteractionCompleted completed and onInteractionEnded ended events. However, if I make it false, that means I need to end the interaction manually with the endInteraction function. This is very useful if you want your interaction to be, for example, delayed. Okay, and last but not least, all of these onInteraction events are being replicated. However, in our old system, we also have the ability to just do very simple interactions, like you only create an actor, you're gonna assign an interface to him, and you're gonna use your custom code in there. That's what we left in this system as well. So if I go back into the interaction detector component, that's why we have these functions over here, because it's from our interaction target interface. If you decide to use these ones instead of using our interaction component, keep in mind that no additional logic is being done with these interface functions. So everything is going to depend on your custom logic. And the last but not least, we have added the UI control system, where you can decide if you want to use the basic user interface 2D, or you want to use the user interface in the world space. Or if you don't want to use any of them, you can just plug in your custom UI logic. Okay, so first let's talk about the user interface 2D. So basically, if I open up the interaction component, which is on our interaction target, you can see here that we've added a new variable called interaction widget index. So if I go into the widgets, interaction messages, and over here we got w_interaction message screen. Let's open it up. And this is like our main interaction screen, where we got only the widget switcher, which basically implements all of the UIs that we want to use in the game. So we have provided here some examples. You can switch between, and depending on the index that we have on the interaction component, the widget switcher will gonna choose the proper UI. So for example, if I look at these cubes over here, you can see that the first one has UI like this, but if I hover over the second one, the UI changed. So this way you can change the UI for each of your interaction target very easily. Okay, that was about the 2D user interface, but also you got the option to use the world space UI. If you want to use the world space UI, all you have to do is you have to add a component to your interaction target. So if I open up the screw pickup interaction, you can see that I have already added the interaction world widget. So basically the system checks if the interaction target has this component. If yes, it's gonna create world space UI. If not, it's gonna show the 2D user interface. So if you look at the details panel over here, we got the widget class. So basically you can define here the class you want to create, anchors to bounce top. If you tick this on, the widget will be anchored to the top bounds of the interaction target. If you turn this off, then you can use the socket name. So this is useful if you got like doors and you want to show the world space UI on some exact position. For example, as I said, if you have door and you want to show the UI only at the handle, this way you can just create the socket on the static mesh and you can just put the name here and the system will gonna automatically change the position of the UI to the handle, to the socket. Also, we got the world offset, so you can offset it as much as you want, and then the classic draw at desired size, draw size, and pivot from the widget component. Let's see how it works. So if I hover onto the interaction target, you can see that I've got the world space UI. The same goes for these guys over here. And also, as I mentioned, the socket name, if I look at this door, you can see that the world space UI is now positioned on the handle. For the UI, we have also provided for you some textures you can use for your purpose. We try to cover the most scenarios. You can find the horizontal ones over here, vertical ones in the middle, and the radial ones as well. Thank you guys so much for watching. If you want to, there's also a demo you can download and play to see the interaction yourself. And if you want support, have questions, or you want to join our developer community, you are warmly welcome on our Sumo Studio Discord server. Thank you so much for watching and see you in the next one.